Welcome to the session on Execute Around Method Pattern in Java Part 1. My name is Venkat Subramaniam. I'm going to talk about a pattern that can help us to clean up resources properly. Let's start from familiar grounds first of all and then move towards this pattern. Java 7 introduced this little feature called ARM, or Automatic Resource Management. Let's quickly talk about this feature and see why it is something we should probably not use and consider other options. Assume there is an object called resource which is using external resources. In this contrived example, I'm just going to print a little statement in the constructor saying it's being created. There are two functions that this resource has. I need to clean up this resource because of heavy external resource usage on a timely manner. Let's go ahead and create an object of resource. Let's go ahead and call a bunch of methods on it. So I call the function fn1 first, and then I also call the method fn2 as the second method as well. When I run this code, the resource is being utilized as we can see from the output, but what about the cleanup operation? Well, even if we had written the finalize method, it wouldn't work. I discuss about this in other presentations. Take a look at other presentations related to this topic. But how do I make sure this resource gets cleaned up properly? Well, ARM says we can implement over here an auto-closable interface. This requires the use of a close method. And we could say within the close method, we can implement whatever logic we are interested in implementing. Well, in this example, I'll simply go ahead and output a little message called cleaning up. And that is all I'm going to do to indicate that the resource has been cleaned up properly at the very end of this operation. But unfortunately, though, if I run this code now, you can notice the cleanup did not quite happen. While the intentions of ARM is really good, it still requires us to make sure we put the try block around this, and then when we put this code we are interested in executing in this resource managed situation, we can see that it is executing and closing the resource properly. Now, while this is effective as long as we use the try block, it requires programmer discipline. Well, there's nothing wrong with expecting programmer discipline in general, but the more we expect of them, the more we're going to fail. And the reason I know this is because I'm a programmer and I do have a certain amount of discipline, but a lot of times expecting discipline all the time is like requesting a person to have sainthood. I am not that disciplined at all. I like to focus my effort on doing things really interesting and intelligent, and little mundane things has to be taken care for me, and that is why I'm not a big fan of ARM approach. I want an approach that is less error prone, where as a programmer, I don't have to say, oh dear, I forgot. What if it's very natural? It is the only way the code is going to work all the time. Well, that is what Execute Around Method pattern can provide for us. Execute Around Method pattern was introduced by in the book called Smalltalk Best Practices by Kent Beck. This has been around for a very long time in languages that support Lambda expressions, but we can make use of in Java as well. I'm going to show how we can make use of this in good old Java, and then in part 2 I'll show how we can make use of this in Java 8. So let's make use of the execute around method pattern. What does that really mean? Well, we have a certain piece of code we want to execute, but we want to execute it around a certain logic where a creation happens and a cleanup happens automatically. So in order to do that, let's go ahead and delete this code for a minute. Let's go up here and remove all these parts we are not interested in right now. So let's leave the close method because after all we want to close the resource properly, but let's get rid of the ARM related code. Now if I were to write a resource over here and create an object of the resource for me to use as a programmer, I would right off the bat use the function I care about because this is the logic I'm trying to perform. After all, I wouldn't forget to do that part, isn't it? But unfortunately now the resource is not being cleaned up, and eventually I may realize that it's not being cleaned up, and I may put the resource close method call and realize I have to do it. Well, this is still broken because I have to put the close method in the finally block, but I don't want to go that direction because this requires programmers to remember this and do it over and over correctly. But let's fix this for the programmer so the programmer doesn't have to say, oops, I forgot. The programmer says, well, that's natural. That's the only way I can write code. How can we do that? As a first step, let's make the close method private. Now the programmer comes along, writes the code to call the close, and the compiler says the programmer cannot call the close method. Sure enough, the programmer can say no worries and walk away. Well, it did not clean up the resource. Now we are in trouble. Well, trust me, we actually are in the right direction, a step closer to the problem we want to solve, a step closer to the solution we want to take. So let's next make the resource constructor private. Now the programmer is going to say, I can't even create an object of this class. What's up with that now? Well, now we're going to move the programmer towards the direction we want to take them, the right way to write this code. So remove that as well. We'll come back with these guys in a minute and worry about it. So now that the constructor is private and the close method is private, how could a programmer possibly use this code? In order to do that, we're going to create an interface. The interface we're going to create is called, let's call it as a use resource. How about that? So use resource is the interface we're going to create. Now, I'm putting all this code as non-public within this file, mainly because I'm lazy. I don't want to switch between files and show you things, but typically you could put this in different files and have them as public interfaces, public classes, as it should rightly be. So here I'm going to create a method called a use method, where this method is going to take a resource object as a parameter. So you can see the use resource is accepting, well, we'll call it as an accept over here for lack of better words, and accepts a resource. So the use resource accepts a resource object. This is an interface with just one method. I'm going to then come back to the resource class, and I'm going to write a static method over here, a void method called use, which is going to accept a use resource as a parameter. Now, I can remember as an author of this class to do the right thing just once. I will create an object of resource, and I'll create a try block and a finally block, and within the finally block I will call the close operation on the resource to clean it up. So if you look at the structure of my use method, the use method creates a resource, and then it calls a close when the code block I'm going to call is done, and if there was an exception or not, the close will happen properly. Now within this block of code, I'm going to call the use resource and call its accept method and send the resource we just created. So if you observe the code we just wrote here, the static method use creates a resource, yields the resource to the use resources accept block function, and then cleans up the resource when it comes back. So the way I would use this resource is I would say resource.use, and then within this I need to provide an implementation of use resource. So I'm going to say over here new use resource, and within the accept method I can say resource.fn1 and resource.fn2, which are the methods I really wanted to call in the first place. So if I run this code now, we can see that the output from the output, the resource is being constructed right as we call the use method. So the minute we call the use method, we are going into the use method, and the resource is being created right there. That's the creating we saw. And then it yields the control to the accept method. Within the accept method, we are calling the function fn1, and that's what we are seeing here. Then the call to fn2 we are seeing here. And then when we finish this, we leave this block of code, this function, this block that we wrote right here in the accept method. So we're leaving the accept method, and as a result, our control goes back to the end of the accept method. So we enter the finally block, and the cleanup happens for us automatically, as you can see right here from the very end of this block. Even if there was an exception in the code, the cleanup would happen for us automatically, and so we don't have to worry about it. So this is called the execute around method pattern, because we have executed this piece of code, but around this code we did the pre-op initialization right here and the post-op cleanup as well. So it is sandwiched between the pre-op and the post-op operation around it. Sometimes people call this also as the loan pattern. This is as if you are renting a car from a rental company, and assuming it's a good rental company, they cleaned up the car before they rent it to you. You drive around wherever you want to drive it around, and then when you return it, they check for damages and other things. So this is again like as if it's being given to you in loan, and you are able to use it during that period and then return it back when you are done. So that is what we saw here as a way to implement this code using this so-called execute around method pattern. Now, this can be pretty effective in making sure the programmers don't have to worry about forgetting to do the right things. Now, sure, this code looks a little ceremonious and noisy, and surely it is more noisy than the ARM approach we saw earlier. ARM requires a try block. So yes, I completely agree this is more ceremonious and noisy, but ignore that for a few minutes. We'll come back and solve it in the next section, in the next presentation, part 2 of this. However, focus just on one thing here for a minute. We are not going to say, oops, I forgot. There is only one way to use this resource right now, and that is to call the use method. And if we don't call the use method, we cannot create an object of this resource directly, so we are forced along this path. And once we do this, we can use the resource nicely and we can return it. I used this on a project where we had to perform operations on database transactions. And within a couple of weeks of the project, I noticed that there was a repetitive code everywhere where we would create a transaction, set up details for it, do the operation we want to perform, and check for errors and roll back and log, or if there was no error, commit it. And within a couple of weeks of the project, we saw this emerge in multiple files in our service tier where classes would do the same operation, and where things were different was right in the middle, where the operation we want to perform were different, but the boilerplate code of creating the transaction and then committing a rollback was exactly the same. So quickly we saw this code being copied and pasted, and the middle part being modified, favorably known as template-driven development, isn't it? Well, to eliminate this problem, we created a little transaction factory object, if you will, and it had a method called runInTransaction, which will yield a transaction object to the caller. The caller gets the transaction object, does whatever they want to do, and when they return, the code then was able to check for errors and roll back and log, or commit with proper handling of the transaction. So that boilerplated code was rolled into an execute around method pattern, and we were able to just reuse that code everywhere else. And so we didn't have to really worry about this code being duplicated. And because the code is not duplicated, it removed the effort from the programmers to use it. And when time came to evolve this code, there was one place to make the change rather than hunting every place where we were using this. And that also became better from the design point of view as well. So this execute around method pattern is pretty powerful, and we used the anonymous inner classes in Java for doing this right here. So we could do this in Java 7 or earlier versions as well, because we have had anonymous inner classes in Java for a very long time. So we could do this for any Java code, and we can effectively make use of the execute around method pattern. However, the downside to this approach, as you can see clearly here, is more ceremony in the code, more noise in the code, and we can probably eliminate some of that if we use lambda expressions. So we will talk about that in the next part. We'll go from anonymous methods to lambda expressions, and then explore a few more details as well in continuing with the execute around method pattern.